Design patterns. Design patterns are reusable and proven solutions to common software design problems. They help developers create code that is maintainable, scalable, and easy to understand. Creational patterns deal with object creation. Examples include singleton, factory, and abstract factory. Structural patterns focus on the composition of classes and objects. Examples include adapter, facade, and repository. Behavioral patterns concerned with communication between objects. Examples include strategy, iterator, unit of work, and CQRS, an architectural pattern combining structural and behavioral aspects. Singleton patterns. The singleton design pattern ensures that a class has only one instance and provides a global point of access to that instance. It is particularly useful for scenarios where a single shared resource is required, such as logging, caching, configuration settings, or database connection. Let's look at the example. Factory design patterns. The factory design pattern provides a way to create objects without specifying the exact class of object that will be created. It is particularly useful when we have multiple classes sharing a common interface but requiring different implementations. Let's look at the example. Scenario. In an order management system, consider different types of orders: online orders, store orders, and bulk orders. Each type of order has a common interface, but their implementations differ. Example: processing fees, shipping methods, or notifications. The factory pattern can be used to create instances of these order types dynamically based on the input or context. Repository patterns. The repository pattern abstracts the data access logic, acting as a mediator between the domain business logic and the data source. It provides a consistent interface to perform CRUD operations, allowing you to change the underlying data storage, example from SQL to NoSQL, without affecting the application logic. This pattern is particularly useful in scenarios like domain-driven design or RESTful APIs for handling create, read, update, and delete operations. Let's look at the example. Scenario. In an order management system, OMS, we manage orders stored in a database. Using the repository pattern, we can abstract the logic for accessing the database so that the business logic, example, creating, fetching, or updating orders, doesn't depend on specific database queries or technologies. Unity of work patterns. The unit of work pattern helps manage transactions in a consistent way by grouping multiple database operations, insert, update, delete, into a single unit. If any operation fails, the entire transaction can be rolled back. This ensures data integrity and makes the application easier to maintain and test. Let's look at the example. Scenario. Imagine an order management system, OMS, where a user places an order. When an order is placed, multiple actions need to occur. Create a new order record. Deduct the stock quantity of the ordered items. Log the transaction in the audit table. These actions should either succeed together or fail as a group. Using the unit of work pattern ensures this. CQRS patterns. The command query responsibility segregation, CQRS pattern is a design approach that separates read and write operations into distinct models, often implemented in different classes or interfaces. This separation makes the system more scalable, maintainable, and better optimized for performance. Let's look at the example.